Hello and welcome to Advanced Programming Techniques. You may or may not know, but all data structures can be expressed with just two operations, the Cartesian product and the union. They appear everywhere in all programming languages, but programmers often don't realize it. In Python, Cartesian product is represented using tuples. In Java, all classes are nothing more than tuples too, except that you can give nice descriptive names to all the fields. In C and C++, it's the same as in Java. It's very easy to see why classes are tuples, especially when you write it like this. The parameter for Z constructor even looks a little bit like tuple notation from Python. However, noticing unions is much less obvious. A union of x and y is when you allow for assigning either values of x or y to variable z. In Python, all unions are implicit. It's the programmer who has to remember what values can be assigned where. In Java, we cannot assign values ad hoc. The role of unions is taken by the polymorphism instead. Consider this example. Here, the class Z has two implementations, and one of them allows for storing x, while the other allows for values of y. Then we can assign either of those implementations to any variable of Z. Hence, Z either carries values of x or y. Notice that those two classes implementing interface Z are unary tuples themselves. In C, unions are supported directly by the language. You might also observe that Java classes and polymorphism can be directly translated into C as follows. So by this point, you should see that classes are the same as tuples, but that's not all. The function arguments are in fact tuples as well. We can show this using some simple mathematics. Take a look at this equation. One of the most fundamental tricks that anybody learns at school is multiplication of both sides of the equation. As a result, we can get a completely new equation that looks different but is equivalent to the old one. In programming, it actually works the same. Take a look at this Python code. It assigns lambda expression to a variable z. We can take both sides and apply to them a unary tuple. Next, we apply this tuple to the lambda expression and the x is replaced with z. As a result, we obtain this. Now, it almost looks like a Python definition of a function. We just need to rewrite it a little to correct the syntax. In this way, we successfully transformed lambda expression into a Python function. Now you can see that all parameters are in fact tuples.